Hello everyone, my name is Adrian, and for this year's personal project, I will design and build a miniature house that is specifically meant to be efficient and suitable for tropical climates. However, in tropical countries, there are many variables to think about, such as heat, temperature, humidity, sunlight, wind, and diseases. Therefore, I have decided and concluded to design a tropical house that is efficient and has a healthy environment that utilizes natural resources. The global context that will relate to my personal project is scientific and technical innovation because I am trying to creatively find a way to make a self-sustaining house that is eco-friendly. As for my idea for the ventilation system, I will apply the cross-ventilation system. So it works when the cold air enters from the bottom through the vents and the hot air will exit from the top vents. To test the efficiency of the ventilation system, what I'm seeing here is the experiment for the cold air simulation. For the cold air simulation, I use the fog of dry ice because it acts like cold air in real life. It works that way because the fog from dry ice is heavier and denser than normal air. As for the hot air simulation, I use the smoke from incense. The reason behind it is because the smoke that it produces rises up like what hot air would do. Therefore, it can simulate hot air. Thus, this is a perfect simulation for the hot air. As you can see, the hot air tends to exit from the top vents because hot air rises up and the highest point in this house is the top vents. Therefore, the vents must be big and open. Other than that, it also exits from the doors upstairs and downstairs, which make it more efficient and let the air circulate faster. When the air circulates faster, it tends to keep the temperature inside low. The reason behind it is because the hot air will exit as soon as possible and cold air will enter as soon as possible. Here is just some other way how the hot air could exit the house. As you can see, I also apply the cross ventilation system on the bottom floor as well to maximize the airflow capabilities. And here is another example of the airflow capabilities from the back door. Here is the overview for the hot air simulation. Other than the ventilation system, sunlight also matters as I design it to use more natural light and use less light bulbs. Therefore, it will reduce the electricity consumption significantly. However, I also minimize the direct sunlight that enters the house to reduce the greenhouse effect in the house. The other features that the house have are 264 square meters of solar panels producing around 580 kilowatt hours per day. Then it also have an absorption well as well as rainwater containment. And finally, thank you for listening.